Hello, Tensor friends. Here is a solution to the problem from yesterday. Was posted on 7 the 14. The problem was given the components of the metric tensor in spherical coordinates, so there's three. All the off diagonal elements are zero, right? First, find the determinant G, determinant of this, then the volume element, which is the square root of G, then find the divergence in spherical coordinates using this generalized equation that we derived. Okay? So the determinant is just this times that plus that times that, which is r to the fourth sine squared theta. The volume element then is the square root of that, which is just r squared sine theta. Okay. Now we want to use this equation. All right. So let's expand it first and look at it. All right. So we got 1 over the volume element, which is this. All right. In the first case, it's going to be the partial respect to r. Here's the volume element there, and the component VR, plus partial respect to theta, volume element component, partial respect to phi, volume element, and the component phi. Okay? So let's see. Now this and this are both products of R, are functions of R, so we have to use a product rule here, right? So it's going to be and sine theta is just a constant, so it's going to be the first times the second plus the second times root of the first. So the derivative of this with respect to r is 2r. We keep the sine theta. Okay, for this one now, sine theta and v theta are both functions of theta. So we have to use the product rule again. So first times root of the second plus the second times root of the first. R squared is just a constant. And the derivative of sine is cosine. Now for this one, neither r squared sine theta, this is not a function of phi, but this is. So that just becomes a constant. We got the partial of v phi with respect to phi. Okay, and let's see, we gather everything together that looks alike, and we say, okay, this totally cancels that, so we just get this. The sine theta is canceled by this. That r cancels one of these. We're just left with 2 over r, VR, plus this completely cancels that. Left with this, plus this r squared takes out that one. And we're left with cosine theta over sine theta, which is cotangent to theta, v theta. And this completely erases that, which gives this. Okay? So that is the answer. And here is the way we did this when we used the Christoffel, the symbols. Remember, that was a problem before this one. And if you look at this, it's exactly the same answer. So that equation, which has the Christoffels in it, which gives 9 plus 3, gives 12 terms. It was lengthy, but it does give the exact same answer. Now, in the literature, you're going to see this written in the sexy form, which they love to do, where they express this as differentials. Do you see? So if you work out this product rule here, and you can see that cancels that, you're going to get exactly the same thing here.